Good afternoon and welcome to CS240. This is Intro to Systems Programming, and this is the end of Act 1. So really, this is the beginning of our journey as computer scientists building out web services. So I felt like the thing that made the most sense is let's actually talk about web services. Let's talk about what we can actually do. So web services are going to be anything that relies on the HTTP protocol to communicate data. So we now know what HTTP is. You are working on right now as part of MP5 a C program that actually reads HTTP packets. So you're going to have a deep understanding of exactly what HTTP is, and you're working on parsing those packets right now as part of MP5. Web services are going to generally be divided up into 3 different categories. So as we talk about things we can do with web services, every web service we're going to build is either going to be one of these 3 types of services. And in fact, a lot of what we build are going to be a little bit of a hybrid of all 3. So the first thing is we can talk about building static web services. So static web services are the simplest and easiest ones for us to build. So there's a lot of websites out there that run as static web services. And the key idea behind a static web service is that when we make a request, so here is a HTTP request. So for example, this is just a simple GET request. And if we look at this GET request says, I'm going to get the page /CS240/fall2021. And the host that I'm actually reaching out to is courses.granger.illinois.edu. So this is the CS240 course website. And this CS240 website serves the exact same page no matter who you are. So the thing with a static website is so this is always going to serve, or we can say reply, with the exact same content. So the reply that's made on a static web server is always going to be the exact same thing. When I have a file like index.html on a static web server, you're going to get the same index.html no matter where you're requesting it from or who you're requesting it as. Nothing changes. So there's a lot of advantages on building static web servers. So one huge advantage is that this is going to be extremely fast. Minimal processing. So if all your web service is doing, if all you're doing is reading a file from disk or possibly even from memory and sending that file out, that is super, super fast. There doesn't require much CPU logic to say, okay, here's a file, I'm just going to ship the same file to every single person. That's fast. And because every single person gets the exact same file, another huge advantage is that it's cacheable. So that means even if I send this, when I send this request out, if maybe Jake is in the middle of the internet, he can then send the request out to the rest of you because we know that as long as Jake gets the latest information, every 15 minutes or so, your page will never be so far out of date. So the way I've set up the 240 website is as a static web server. Basically, every single person who visits a particular page on the CS240 website is going to see the exact same content. And in fact, by default, it's set up to cache pages for like an hour. So you're not going to re-request the page unless you refresh it for an hour. So sometimes if you're like checking the page right before lecture and then check the page after at lecture, because it's been less than an hour, you might even have to refresh the page if I've posted the notes in that period of time. So it's cacheable, it's extremely fast. But there are some disadvantages to it. So because it's cacheable, because it's fast, because everyone receives the same content, the disadvantage is that there's no user customization, no user level customization. So that means no login or anything like that. On a purely static website, you're not going to have any user login. You can't customize it to different users. So you don't log into the CS240 website, for example. There's no customization for you versus everyone else out there. So there's, even on really, really complex websites, you still have some form of a static server. Because, for example, an image file usually is the same image file no matter who's viewing the website. So even if Gmail is customized just to you, you still see the same Google M icon on Gmail. That is static content within a non-static website. So anytime we build a service that simply loads a file from disk or memory or anywhere else and serves that same file to everyone else, we call that a static web service. Static meaning it does not change. It's always present, always the same. So that's the first type of web services that we're going to be building in the second part of this course. But that's not the only type of web service. So the second type of web service is the primary form of APIs that you're going to work with. So the second form of web services are what we call Restful Web Services. Sometimes you just hear them called Restful Apis. And Restful APIs are a specific type of web services that allow us to get formatted data back from a service. So this returns formatted data from a web service. So there are a ton of different APIs out there. And we're going to talk about what actually makes an API RESTful. But I think the first thing to do is let's look at what that looks like. So the National Weather Service provides an API to get us weather data. So if you look at their documentation, I found that one URL that should work is if we go to https://api.weather.gov/points and then provide the longitude and the latitude of our current location, we should be able to get a forecast of what the weather is going to be like at that particular location. So we can use this web service to actually say, what is the weather going to be like here in KIF or SIF or however you pronounce CIF? So in this very building, what's the web going to be, or what's the weather going to look like? So to do that, the only thing I need is I need the GPS coordinates for this location. So luckily for this, Google Maps is really useful. So I'm going to go over to Chrome, do Google Maps, and let's see, here we are. If I zoom in, awesome, classroom instructional facility. Here we are, we're right in the center of the building. So if I right click on Google Maps, it gives me this nice drop down. And if I click on this, it actually copies the GPS coordinates to my clipboard. So this is super convenient. So now, if I simply go to https://api.weather.gov/points and then paste in these the coordinates and get rid of the space that Google added for me. And I think it's points. It is points. And I did not type API. Hello, API. What I get back is I get a formatted stream of data that is specific to my particular location, and I get a bunch of different stuff. I get blah, 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 blah. Here's my point. Here's the exact coordinates I got. And let's get some relevant information. So the weather right now is the wind looks like it's at 275 degrees. I don't even see a temperature in here. But what this does give me is it gives me another URL to the forecast, for example. So if I want the forecast, I can then follow this URL stream down. And it says, OK, here's a forecast. So for this afternoon, we expect the high temperature to be about 75 degrees Fahrenheit. So basically, I'm making a request for the GPS coordinates based on the API from National Weather Service. It gave me back formatted data. That formatted data gave me some information. It also gave me additional URLs to go get more formatted data so that I can now read weather information. So you may have used APIs before, but this class, we're going to be focusing on building these ourselves and also using other people's APIs to help us build even more amazing things. So this is a RESTful API. We're able to make a web request to a service and get formatted data back. The beautiful thing about formatted data is once we understand how the data is formatted, we can build apps with this data. So a RESTful API is going to, so the request is get/points, and then we actually had the GPS coordinates of our points. So our GPS was 40.1, so basically 40.1, comma, negative 88.2 was the actual request that was made. So that's the request that was made. That request returned formatted data to us. So there are a few requirements that we have to have if we're going to be building a RESTful API. And we know that everything that advertises itself as a RESTful API are going to meet these requirements. So I go back to that. So what are the requirements? Requirements for a RESTful API. The first thing that we have to have is it has to be, obviously, a web service. Must be an HTTP web service. So if someone tells you about a RESTful API, you know that that RESTful API is going to talk in HTTP. That's the protocol it's going to use. It's going to send and receive HTTP packets. So we know how we're going to be able to communicate with that service. The second thing is that it must be stateless. So what stateless means is that it means that it does not remember anything about the previous request or the next request. That means all of the information that you need to get the data that you're receiving from the server is contained within one request. So no dependency on a previous request. So if you need a ton of information to get in what you need to know, you got to include that entire thing in your request. So here, the only thing I need to know is I need to know the GPS coordinates. So notice I had to put the GPS coordinates in the request that got me the information back. So every single RESTful API must be stateless. The third thing is it must be cacheable. So the content must be content that is going to be able to be read for some amount of time afterwards. So it's not going to be live content. It's not going to be a video stream. It's going to be information that's going to be relevant for some period of time. The fourth thing is it must be client-server based. So the idea here is that you have to have a single client talking to a web service. This kind of gets wrapped into the first one. And the final thing that we're going to talk about is it must be on demand. So a RESTful API must give you a response back when it replies to your request. So it must be able to provide the data to you immediately. It's not going to basically be like, okay, I hear you made this request. I will send you an email later. The RESTful API must complete the request in its entirety when you make that request. There may be things that generate an email. It may complete the entire job of the RESTful API, and that may generate an email, but it's going to serve its purpose immediately. It's not going to say, hey, check back 2 minutes later. It's on demand. So every single RESTful API is going to follow these 5 categories. So whenever we see something into RESTful API, we know that that's going to completely be true. So what this is doing is now we've got this kind of 2 different universes. We can have a static web server that just serves the entire same thing to every single person, or we can have this RESTful API that is a stateless API where you can make a request to the service is going to return information to you, and that information is going to be the same for the same set of for the same parameters, but now it's in a formatted data way, or the data is formatted in a way that we as programmers can actually make use of this. So this is really awesome. We love RESTful APIs. And this is how the modern web pretty much works, is it works on APIs. So you can imagine, as we're writing a server, instead of just replying with the file, like you're doing in MP5, you might reply with specific logic. You might say, like, okay, if you give me this GPS coordinate, I'm going to look at my database and see what the weather is for that GPS coordinate and return that database information. So there's going to be more complexity to a RESTful API than a static website. And then the third and final web service category is going to be stateful web services. So we said that RESTful APIs were stateless, that all of the information about your request is contained in the packet that you send, is contained in the request packet. Static web services return the same thing no matter what your request packet looks like. So if you need to have a multiple packet session, you're going to build the most complex type of web service. And that's going to be a stateful web service. So one website that I built with students like 6 years ago when I was teaching CS 225 was the Q at Illinois. So as part of that, we had to make the design decision on how are we going to build this app. Are we going to build it as a simple static website? Well, we need people to log in, so that doesn't really work. Are we going to build it as a RESTful API? There's a bunch of RESTful APIs inside of it, but we do need some state, like where are you on the queue? Who is the current core staff on the queue? So we need some stateful information about your state in the queue. So q.illinois.edu is going to has components, it uses actually all 3 of these, but the core functionality of Q requires us to know state. So when you send a packet, whenever you do an event, you actually send a packet with a whole bunch of state about who you are. So for example, if I go into the queue, I can do post, and this is an HTTP verb that we'll talk about, and I'm going to post to a particular endpoint. So this says I'm going to post about queue number 788, and this post was actually related to me adding myself as a member of staff so that I can actually answer your questions on the queue. And then the host was q.illinois.edu, and the content length here is 477. So the previous 2 packets we looked at had no content, had no payload. It only had headers. Here now, I'm sending all of my state to the server so the server can reply back. So there's a whole bunch of state here. The state is organized as a dictionary, specifically a JSON. And you'll see that I have a bunch of information about the current state of my request. So as part of this, you'll see that it's QID 788. My user ID on the queue is I'm user 1, and a whole bunch of other stuff. So what we can see is every time you make one of these requests, the beautiful thing is Chrome actually shows you the request that's being made. So this is one of the great things about web services. You can actually inspect how real web services work. So if I go to the queue, I can actually see this packet. So if I go to queue.illinois.edu, and if I log into the queue and do the 2FA, and then if I go to CS240's queue, one thing that's really awesome is that Chrome and Firefox and any modern web browser allows you to inspect a page, and you can choose to look at the network thing. And this network records every single packet that's being sent. So I'm choosing the network tab once I've inspected the page. And what I'm going to do is I'm going to join the queue. And having done that, I can see this made a request. So there was an HTTP request that was made to the queue web server to say that I have joined the queue. And if we look at that, if we preview the request, you can see the headers. You can see the content link that's 477. You can see all of the information about the HTTP request that's being made. So all of the things that you're doing right now of talking about how you build HTTP requests and what HTTP requests do and how the inner works of HTTP works is done just so that we can have communication with a web service and we can build things like Q or any other web service that you want to build. And you're going to have an understanding of how this actually works. And then, of course, if I leave the queue, if I leave being on staff, so if I leave, there's going to be another packet that's sent that also has me leaving the queue, leaving staff. So that's telling the server that I want to update my state so I'm no longer working the queue. So now remove me from the list of on-duty staff. And these are done through stateful HTTP requests. Any questions on this? So these are going to be the three, oh yeah, Jake. Yeah, they're all used a ton. Generally, so the first one, the static web service, that's going to be the simplest. If you're just hosting an image, you're going to use a static web service to host the image because the image that you're sending, unless you're doing something very fancy, is the same for everyone, right? So we didn't have any graphic designers on this team, so I don't think there's a single image in all of this. I think everything here are just emoji characters. So there's no images, but if we go to like the front page of Q, we have a video. Still don't even think there's an, oh, I guess these guys may be images. Yes, okay. So like this is an image right here. Actually, the whole front page is actually a static website. So this whole thing, no matter who you are, you see the same front page at q.illinois.edu. So this is actually a static website. And if you notice on the URL, everything inside the Q is /Q, the letter Q. So if I change the URL over to here, you see illinois.edu/q/q. So everything that's hosted on the root of the service is a static web service. Everyone sees the same thing. As soon as you go into /q, all of that's now actually hosted on a next.js server. So that's now no longer a static website. And you're going to see we're going to use a hybrid of different technologies. Sometimes I need a stateful request, but sometimes I just need to serve static content. So again, like images. Everyone sees the same image, even on a website like that, so that can be just hosted statically. That can be done very quickly. So static content, static web service is extremely fast, extremely quick. Low CPU cost. Restful APIs, kind of medium cost, great for communicating with web applications. Stateful web services, extremely high cost. You usually need a database or other form of state management behind the scenes. So I try and make projects that don't require any state. I try and make things that are either stateless, static web services, or I try and make things that are RESTful APIs. I really, really try and avoid building stateful web services unless I absolutely have to. But there's not an objective truth, because I build a ton of static content. Like, this is everything I build is static sites. So, and you can build a lot of dynamic static sites. So like, one project that got some, like, we have these LinkedIn banner generators and stuff. So like, I worked with a senior who did this as a senior thesis, where you can make these like fancy Illinois themed LinkedIn banners. I can say, hey, I'm Wade Fagen-Ulmschneider, University of Illinois. I'm a Granger, whatever. And I have this dynamic content on this page, but everyone still receives the exact same thing. And I can even do the download. Like, none of this actually makes any requests out to my server. Everything that's needed is downloaded as soon as you get to this page. So this makes the server cost really, really cheap. Because all it's doing is saying the same static site. This is different than, so one site that I know, so another person like that programs a ton of stuff is, how many of you guys had Challen in 124 or 125? Jeff Challen. So that website, he takes the other extreme, where that website, literally everything you do, like, you log into the website. He tracks you every single page view you make. I think he tracks like every time you click forward on the next slide, right? And I think, is that still true? You get extra credit for like clicking through the slides? Yeah. So like every single thing you're doing is a stateful request. So if you go to like CS 124, and then if I were to inspect this page, you're going to see that instead of just downloading one thing, as I move between pages, I mean, just by hovering over this, I'm having network requests. Like, he's stalking where my mouse is hovering over to know, like, what am I hovering over on this page? Because there's already been 4 web requests made just by clicking the menu. So I can go like info and be like, okay, what people are involved? Okay, so these are the people that's involved with this. So there's a ton of different requests. A few of these were the images that are made as a part of going through this page. So everything here isn't actually a static website. It receives information about who's on staff. And in fact, if I look at these requests, I'm going to guess there's going to be a page that I can get at that app data, page data. So all of these pages, so if I go to preview, here's the profile, results. So all of these things are RESTful or stateful API requests that are giving me state information about the requests that I'm making to get information about the actual page. So this is a completely different design. I don't know if anyone knows. So this obviously looks like React. I don't know if he's using Next.js or what the backend technology he's using to serve it. I don't know if anyone knows. But there's going to be some site that every time you visit it, it's serving you JSON to decide what you're actually going to render. So you can get different information different times you view it. So that's a different, so he's got a huge course that's really great. He's into building these stateful web requests that you're tracking every single moment of time. Once you visit the 240 website or any of my websites, like, I don't care what you're doing. I don't want to stalk you. So I don't have any of that technology, and I don't basically I send you the same request as anyone else. So if you view the website, you're going to get the same static content. And that's just a design decision, and there's no right answer. There are advantages and disadvantages to both of them. Cool. Any questions on web service types? We're going to see all 3 of them throughout the rest of the semester. And we're going to talk about why do we choose one or the other. So one thing I did want to mention is there are certain, there are verbs that are defined in an RFC. So request for comment, these are the standards. You guys have read standard documents in both the PNG standard and the HTTP standard. And the HTTP standard defines a few different action verbs of ways you can communicate with the service. So one verb that it defines is the get verb. And this is a default verb. And if you make a request, so if you just make a simple web request, or I'm going to say a standard request, like if you go to a page from a web browser, it's going to send you a GET request. And a GET request simply asks the server to retrieve data from that particular location. So if you look at all of these pages, this was a GET request. I'm getting a web page from the 240 website. I am getting the points, the weather forecast for a particular point. These are GET requests. And GET requests are the most standard form of requests. A POST request, on the other hand, is sending data to a web service, often causing a change in state. So if you see that when I looked at adding myself to the queue as core staff, that was a POST request. I know that I wanted the server to change the state of how the service is currently running. So if I want to inform the server that as a user application, I want something to change, I'm going to format my request as a POST request. And this says anything that's a POST request is going to change the state of the service. These are the two common forms of requests. I would say 95% of what you work with in the, on a standard website is either going to be GET or it's going to be POST. Those are the two verbs that you see happen the most. On the other hand, there are 4 verbs that happen occasionally. So head is the same as GET, except for it says, don't give me the content, just give me the headers. So this allows us to check whether or not like the page has changed since we last saw it. So you often just send a head request to say, hey, I've seen this page like an hour ago, have you updated it? Let me know just the headers so I can see if the update time and the content length has changed. If the update time and the content length hasn't changed, I'm just going to show the user the old version of the website because I know it hasn't changed. So head is similar to GET. So that's a response identical to a GET, but without the response body. 3 other verbs is put. So if you want to add something, you can put something. Another verb is delete. Third verb is patch. These are also pretty common. So I would say this makes up, the get and push, or the get and post makes up like 95% of stuff. The put requests, or sorry, these 4 requests make up the other 5%. So these are not rare, but somewhat uncommon. Yeah?
What happens if you wanted to submit a request that retrieves some information, but also changes what's going on in the database in the background? Would you have to separate those into a separate GET and POST request?
So we're the programmers of the server, so we can decide exactly what we want to do. Okay. I would recommend, like, if it's 2 different user flows, like sometimes you just want to get the information, and sometimes you want to get the information and change the database, I would separate them out. Because that way you can reuse the code when you want to just get the information. But if you obviously always are going to have the database and then retrieve, if you always have that one workflow and there's no reason for the separate workflow, combine them.
Okay. And you could just put that all in like one POST request?
Yeah. Yeah, the POST, these are just kind of what the standard tells us works. And certainly like this POST request, this is the request. When I make this request to the queue, it modifies the database and then sends back as a response a confirmation the database was modified. And that confirmation tells me to update the user screen so that it now sees that they're no longer part of the queue or still part of the queue. It's not unusual. Conventions are tough. Lots of people have lots of thoughts on it. It's not unusual. Lots of people do it that way. Yeah, Chick. How common is patch used? Occasionally. I've seen it used a few times, especially when you want to, some people use it to change a record. Like basically if you, I don't know, if you unliked a post on Instagram or something, that might be a patch. That says, it may also be a post, I'm not sure exactly how they do it, but if you inspect Instagram, like if you take away a heart, it's sort of like changing a request you made earlier. Yeah, I mean, we're going to be the actual programmers, so these are the conventions that we're going to try and follow. You can make a post do whatever you want. These are just to make it easier to communicate with other programmers. If you're going to publish an API, you can say, okay, this call does this. I know the GitHub API does have several patch commands, and that's where I think I've used patch, is the github.com API. Now, the bottom three requests, I have never, ever, to my memory, ever used any of these three. So the HTTP standard defines a verb called connect, a verb called options, a verb called trace. It's defined. I've never used them. I don't know if anyone here has ever used any of these three. I have not. These seem to be, they exist. They seem to be very, very, very rare. So even though they exist in standard, I haven't seen them out in the wild. So any questions on verbs? So one point I want to make before I finish talking about this is there is this principle on why the web actually works. And we go through this and we say that these are very loose standards. And in fact, that's going to be the theme that we're going to hear throughout this entire rest of the course. Is everything we're going to talk about is we're going to talk about what the standards documents suggest that we do. The standard documents don't really define, you absolutely must do X. Should you use a push, or should you use a put or a post? Those are going to become design decisions that you as programmers are going to make. Should you post to the server or should you put to the server? What makes the most sense from an API point of view? Should you put or should you patch? These are going to be decisions that we make as API designers on how do you want your API to interact with the world. If you want to tell someone how to interact with your system, you should conform as much as you can to the standard, but also understand that people are doing their best. So what you see is that there's going to be a lot of APIs that you're going to work with that are going to kind of say it does one thing, but kind of has a little bit of an error, doesn't quite have the field in the exact way that it claims in documentation. So one principle on web is you're going to try and make your stuff as best as possible, but when you're reading APIs from other people, you should be as accepting and as general as possible in your code. Because working with other people's code, you know the kind of seg faults you've made and other errors. So there's this principle of designing web services. You try and make them as forgiving and as accepting as possible. You're going to try and want to make sure that your user actually gets a response. You want to give your user a really, really powerful experience. So you should try and make the best of whatever request or whatever the request the user sends or whatever request you get back from your internal APIs or some external API. So make sure to try and program the best thing possible, but also be accepting of kind of bad requests from someone else. Any questions so far? Yeah, Aaron.
Are these most relevant to Restful APIs, or are there like such a ways of how like browsers sort of send requests?
Yeah, so are these true for browsers sending requests as well? And the answer is generally yes. So Chrome's like very good at sending well-formatted requests. But honestly, you can just give Chrome absolute crap back, and Chrome generally renders something. Like Chrome is very, very good about sort of just taking whatever you give it and trying to make sense of it. So in fact, on MP5, the MP we're working on part 3, we're actually having you set up a packet to send a file back to Chrome. Chrome really would love a lot more headers than we're going to give it. So once you work on part 3, literally as long as you send that first line of an HTTP response and a content length, that's all you need, and Chrome will and the meta and the content type. So there's basically 3 headers that are absolutely required in a response for MP5. You need the status line, the content length, and the content type. Chrome would love a bunch of other stuff. It would love more data about what you're giving it. But as long as you have those 3 things, Chrome will figure it out. So in MP5, you'll see that you're actually going to test your MP5 part 3 with Chrome itself or any other web browser. So they apply that same principle. Chrome will basically take any crap you give it and try and make sense of it. And it does that with HTML as well. Like HTML, there are some badly formatted web pages out there that Chrome makes sense of. Yeah. Yeah. Yep, everything's the same for Safari, Firefox, Edge. Yeah, all the same. They all speak HTTP, and that's one of the beauties of standards, is a standard committee where people from lots of different companies and universities came together and decided this is the best thing we could come up with to share with the world of how we think web pages should work. And they publish that standard, and people take a look at it, and they're like, oh yeah, this is pretty good, we're going to use this. And because a whole bunch of people use it, then it becomes the accepted standard. So there were other things there was something called a Gopher Protocol way back before HTTP that communicated how do you share websites over the internet prior to HTTP. And the Gopher Protocol, people used it, but it had some problems. They're like, this is not great. So it got some adoption, but HTTP was better. So over time, HTTP won out. So because there's some standard that everyone agrees to use, we're able to communicate. And that's generally how new standards come about. There's lots of different people with different ideas. The best idea hopefully rises to the top. One of the things that if you get into like some of the kind of ethical debate around like Google Chrome's dominance is that Google Chrome now controls like 70% of the market share of the internet. So that means Google is at the position where they don't really need to talk to anyone. They can just change something, even if it's not the best idea. And because they control 70% of the internet, people are going to accept the change because everyone's using their browser. So from an open standards point of view, that's really dangerous. Because now we have a single company that's not talking to anyone else, deciding to make a change and say, you know what, we're going to add this to the web standard, or we're going to remove this from the web standard. And we're not going to talk to anyone. We're not going to decide if this is a good idea. We're just going to do it because we feel like it. And that's really dangerous. And that's part of the reason that there's a lot of, that it's important that we have other browsers like Safari, even though it's built on WebKit, which I think is now built on Chromium, and Firefox, because Firefox is completely independent. So what renders a web page in Firefox is completely different than what renders a web page in Chrome. So that's kind of some of the nitty-gritty as you go into kind of the kind of why do standards matter. Does that kind of help? Cool. Anything else? Thoughts? Yeah. RESTful services and static services mutually exclusive? No. In fact, I think most static services technically qualify as RESTful services. We generally call RESTful services things that respond in formatted data. And static services are things that respond with content. So you can say a RESTful service is a static server, but we kind of delimitate the two based on the type of responses they give back. Question or no? No? Okay. Cool. So then so now that you understand the basics of how web requests are made, and in MP5, you're actually going to be programming HTTP web server, and you're going to be sending a static page back as part of part 3. And you're going to be parsing HTTP header, and you're going to understand how the HTTP request is actually being made. We are now at the point that I want to start working with you on building high-level applications. I think, especially in the exam that you're taking right now this week, you're going to show to me that you get all this low-level stuff. You've mastered this stuff. You are a systems programmer. And now I want you to be a systems programmer in the cloud. I want us to think about how do we design applications that go at a cloud scale level? How do we build things that have multiple computers and multiple services interacting with each other? What are the challenges that come with that? And to do that, the problems that we're going to start focusing on is less going to be at the byte level. So that's going to be like, okay, where is the colon space here? Where is the /r/n? Where is the PNG header? Where is the PNG signature? Where is each chunk? How do I allocate a bunch of things? So because the challenges that we're facing are changing, the tool that we're going to use is changing too. So at this point, it doesn't matter what high-level tool we use. This exact same thing, everything we say could be true about Python. It can be true about JavaScript. It can be true about .NET. And those are really the only 3 languages I see used a lot in this space. But you could do all of this in C#, you could do all of this in JavaScript, you could do all of this in Python. A couple weeks ago, I asked you guys, do you prefer JavaScript or Python? And I think there was 1 Python holdout. I think Jake and I were there 2. Who else was Python or Team JavaScript? Just you and I? Yeah. So we could do this in JavaScript. You guys said Python's your preferred language. So we're going to do this in Python. So if you've never done Python before, I want to just give you a very, very high-level overview of Python. And if you have, just kind of give you a reminder of what makes Python special. So first, Python is an interpreted programming language. There is no need to compile Python code. You don't compile Python. So there is no process, there's no GCC Python and then end up running a compiled piece of code. Instead, you run the program directly. So to run a Python script, you run Python, then server.py. So this runs the Python script. There's no need to compile. There's no multiple step process. There's no making and then running it. Because it's interpreted, it just starts running the program as soon as you invoke it. So there's no compile step. So Python is also a dynamically typed language. So that means there is no variable types. Required in code. So what that means is that there's no variable types required in code. It doesn't mean things don't have a type, because everything does have a type. Things are still inside of Python, integers or floats or whatever. But to literally declare something, you just say, you give the variable name, like I can say netID is equal to WAF. That's it. I don't have to say string netID. I don't have to say what type netID is. It just implies and infers that netID must be a string. I can even then go to the next line and say netID is equal to 22. And the type of netID has now changed from a string to an integer. So Python is completely dynamically typed. It figures out the type based on the contents of the variable. So we don't have to care about type correctness. One of the biggest challenges about Python versus C is that Python is white space delimited. So that means is white space matters. So in C, you have a control flow statement like an if statement that says if A is less than 5, and you use curly braces to delimit what's contained inside the if statement. Then once you go outside the if statement, you might say, I don't know, B is equal to 6. So in C, semicolon, you have this code that you have this if statement, you have curly braces that delimit what that block of code is that should run inside the if statement. Python has all the same control flow statements as C. They have slightly different syntax. So if we don't need parentheses anymore, we say A is less than 5. But here, we now put a colon instead of a curly brace. And the colon is basically the same as a curly brace inside of C. But the way we decide what's actually inside of the if statement in Python is that we indent the next lines of code. And the indentation is required. So if inside the if statement I say A equals A times 2, and then A plus plus, the same thing happens in Python, but it's indented. A equals A times 2, A plus plus. And then outside of the indentation, if I go backwards, then I say B equals 6, and that's outside of the loop. So this idea of this indentation, where you have to indent to decide what's inside your control flow block, is how Python handles braces. Yeah. I was actually thinking exactly that. So if Python doesn't have plus plus, I think I paused for a second because I was like, I'm not sure if that exists. So A equals A plus 1 if Python doesn't have plus plus. Oh, does it have plus equals? Okay. Say what? Okay. So A equals A plus 1 will do it. I guess Python also has plus equals 1. So apparently it doesn't have plus plus. Sad. But the thing is notice that in C code, all of the lines are delimited. The end of the line is delimited by a semicolon. The end of the line on a Python file is delimited by a new line. There's no semicolon that says this is the end of the line. So in C, you can do disgusting things like putting 18 statements on a single line with semicolons. Python doesn't let you do that. So one of Python's design philosophies is the idea of code readability. So the language itself forces you to have good readable code. Since you can't do some of the disgusting things with control blocks that you can do with C programming, your code ends up being more readable if it runs at all. So Python really tries to focus on code readability. So for example, here is a very, very simple Python program. Just kind of demonstrate what Python programs look like. So we have hello, we have world. The for loops inside Python are for I and list, where the thing at the end of the Python thing, this needs to be a list or a list generator. So basically, we either need something that is its list itself or something that can generate something that is a list, something basically can iterate over something. So range 10, this actually generates the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this for I in range 10 is the same as for I equals 0, I is less than 10, I plus plus. So range is just a function inside Python that actually, I think, returns a generator that generates those numbers. So anything that you can iterate through, you can do for I in whatever. And then here we see that all of this code is indented. So we know that all of this code is within the if statement, or sorry, within the for loop. And in the for loop, we have the if statement, the else if block, and the else block. So notice no more parentheses, no more curly braces. Instead, we have colons to denote that we are in a control flow block, and then indentations to denote what's inside of that control flow block. So if we look at this code, what does this look like it's going to print? First question is, how many lines get outputted? How many lines of output do we have? 10. And what's the first 5 going to say? Hello. And the middle 3 are going to be hello world, and the last few are, yeah, just world. So I have hello.py right here. I'm going to run Python hello.py. And I just copy and pasted this from my slides, and it had fancy things. So if I get the right kind of quotes, hello, 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 hello world, hello world, hello world, and then world at the very end. So notice I run this just by doing python hello.py. That there's no compiling, there was no making and then running a.out. It was a single line of code to run that program. Yeah? Oh, how do test cases work? So you're going to be, there's a world, so there are things like PyTests, which are unit tests in Python. But as you're working with more and more web services, we're going to have, it's going to be more and more for you to test your actual web service. That as you get higher and higher level, there are tools to do it, but part of it is you're going to start making more design decisions on what you're going to build. And as you make those design decisions, you're going to have to test your own design decisions. So you're now going to get even more freedom on exactly what you want to build. So you'll still see some PyTest stuff. We still have some basic stuff, but it's going to be more and more new. Cool. Any other questions? So Python's great. The main reason we use Python, though, is Python has some extremely powerful and amazing libraries. So libraries allow us to extend the functionality of Python, and this is using code that other people have built to do more than what Python does just out of the box. And one of the first libraries we're going to use is this great library called Flask. And Flask is a library that allows us to build HTTP web-based services extremely quickly. So what you'll see is that Python has the ability to include stuff just like the pound includes in C, except for in Python world, we say import. So import Flask from Flask. And this says I'm going to import an object called Flask from the library called Flask. Or sorry, other way. Import an object called Flask from the library Flask. So I want to kind of look at a few different lines of code in this program, because this is the basic program that you're going to be writing as part of MP6. So MP6, which will come out on Thursday, has you build a web service that is very, very simple. All you need to do is you need to build a web service that takes in a PNG file from a website and returns the hidden GIF that's hidden inside of it. So do you have a program that looks at a PNG and gets a hidden GIF out? Is that something you've written? Yes, hopefully, right? That program you wrote, what language is it in? C. So what we're going to see is Python can just call out C code. We'll have C code do all the work, and then Python's just going to return the image. And we're going to put it all in front of a web front end. So basically what we've done is we've taken your MP2 code, which is low-level C, and we're sticking a web front end on top of it by using Python. So you're seeing how we're going to extend the functionality of MP2 and actually make a web front end out of it. So what we're going to do is we're going to use this Flask library, and I want to look at a few different lines. So whenever we want to use library code, we have to import the library code. So generally the statement's going to be from some library, import some function or some class. So from Flask, import the Flask object. From Flask, import the render template function. So this is going to be a key idea that we're going to often call out to different libraries to import functionality. Second thing is comments inside of Flask or inside of Python are done with a pound sign. So, or a hashtag or whatever you want to call this guy. So a pound sign or a hashtag anywhere on the line denotes that the rest of the line is a comment. So you can see I have a few different comments throughout this code. It's always done with the pound sign. The third thing I want to point out are on lines 6 and 12, and that is how do you write functions inside of Python. So Python, you define a functions with the keyword def, and that says I'm going to define a new function. And functions in Python can actually have something called decorations. So this is something that does not exist in C. I think it exists in Java. It exists in JavaScript. It exists in a few programming languages. But we can actually give the functions basically tags or decorations to say this function should do something specific. And what the Flask library allows us to do, allows us to decorate Python functions with information about when should this Python function be called by Flask. So by using the @ sign, this @ sign says that we are decorating the function that comes on the next line. So we're decorating the index function by using the app object and saying that when this Flask application sees a route for the page slash. So it's going to look at the HTTP request that's being sent to your Flask server. It's going to see, is that request looking for slash? If it is looking for slash, it needs to run this code right here. So basically, all the code you're doing on MP5 is what's happening behind the scenes to get the Flask server to realize the route is slash, and then it needs to run that code. Yeah?
So is that by default handling it as a get method, or is it going to be full?
Oh, so if we don't specify method, I think it'll handle any method. So if you post to it, if you get to it, if you patch to it, it's going to go to that route. Yeah. So if we want to specify it only to do certain methods, we can do exactly like this. So if we only want to respond to post methods, this says if you try and get extract, it's not going to respond. So it's saying here on this one, I want this code to only run when someone makes a request to extract, and it's a post request. Yeah. So reason you're importing things separately. So yeah, so one thing you could do is you could import everything at the top, right? So that kind of pollutes the global scope of the whole file. So what I try and do is I try and only import the things I actually need in the particular scope I'm in. So yeah, the other option is, like Aaron said, you could import Flask. And then you could do flask.flask. Or sorry, maybe import lowercase flask. And you could do lowercase flask.flask _name instead of this line. So you could definitely namespace it. It's kind of personal preference. It works. Most of the Flask code you see on the internet is going to actually look like this. That most Flask programmers prefer to import it, not import the entire Flask library. Is there a lot of overhead in importing? I mean, possibly. I'm not actually sure. I don't think there's going to be a ton of overhead if your library is pretty small. But I'm actually not 100% sure. Something like Flask, you're only importing it once, and the server's probably running for days or weeks at a time in production, so it's probably not a big deal. Yeah, Jake? Is there a way to pass variables into these functions? So there are a bunch of global variables that Flask is going to define for you. So you have a variable called request and a variable called response. That is your request packet and your response packet. Those are global variables that are defined for you. So Flask sort of gives you globals instead of passing in things by parameters. So you'll learn some of the quirks about the Flask library as you work with it throughout the semester. So one thing I want to mention is how in the world do we run one of these Flask programs? So you'll notice that this Flask program is entirely functions. So if I were to just run this as a program, if I were to go to app.py and just look at this, the only thing this program itself does is it declares one variable app called Flask, and everything else is just a function. So if I simply run Python app.py, it's going to do nothing. Because by itself, it's kind of a useless program. It defines some functions. Instead, what we've built is we've built a program that runs as a Flask service. So to run a Flask program, you have to do Python -m Flask run. So what we do here by doing Python -m Flask, oops, we don't need. Python -m Flask run. This says I'm going to run Python using the Flask module, and I want to then send to Flask that I want to run an application. So now if I do Python -m Flask run, you'll notice that I get a bunch of output that says, hey, I am now running your app as a service, and it's right now a development service, don't use it in production, so a bunch of warnings. But it says it is now running on 127.0.0.1:5000. So that's running on the localhost port that we talked about. That's running locally on my computer, and it's running on port 5000. So what I can do now is I can go to my web browser and go to http://localhost:5000, and I can see that I am getting the server that I just built to respond to my web requests. And if I look at the slash route, it says that it should return the page index.html. And if I look in my templates directory, I have this static page index.html that says CS240 PNG microservice extract GIF, blah, blah, blah. And it's giving me that exact page in my web browser. And what I can do is I can then post on this. It says broken. Well, why does it say broken? Because this made a post to the method extract. And it did that because in the index.html, I said to make a post to extract when the form was submitted. So I directed the web page to post to extract, and in in app.py, I returned just the word broken and the status code 500. That says right now this endpoint is broken. It's broken because you guys haven't programmed it yet. So you're going to unbreak this code as part of your MP6. So you'll call out to your MP2 code. You'll basically save whatever file that's being sent to the server in some directory, call your MP2 code to extract the GIF, and then whatever GIF is extracted, you'll send that GIF back so that we can see every single one of yours extracted GIFs based on sending in the PNG. So this is just the beginning of our journey in Act 2, where we're using our knowledge of systems programming to actually start building web services. And we're going to be studying what are the different types of web services to build, what are different designs of web services, how in the world do we go about hosting these web services, what in the world does AWS provide for us, or Google Cloud Computing, or Azure. What parts of this is software as a service, or platforms as a service, or infrastructure as a service? And how do we design good cloud scale applications? So I really see the second half of this course as taking all the foundational knowledge you know about systems and starting to apply it to do cloud scale work. So the course, as we go into Python, we're going to be much, much more high level. but we're still going to rely on our knowledge of how things actually work at the low level to help us design the best solutions we can at the high level. So and hopefully you'll see we'll keep pulling back to ideas we saw in the first half of this course, the first act, to influence how we can do the best design philosophies possible as we build cloud scale services. Yeah? Which MP do we start using AWS? So that's actually a question so we can use AWS. One of the biggest, so I looked at anonymous feedback. A lot of people didn't like using like the GitHub tokens and stuff. And AWS actually has even more levels of security than GitHub. So there's a conversation we should have if you want to keep using real tools in here. If we want to use AWS, there's like tons and tons of setup just to do AWS. We can fake it with like a virtual machine. Just like we could fake GitHub with like using GitHub Dev instead of real GitHub. So there are ways we can fake it to make it easier in this class. One of the most negative pieces of feedback I've heard is you guys haven't liked the struggles of using real tools. So one thing I'm going to try and do is use maybe some nicer tools. So we might just fake it on a virtual machine instead of going out to AWS, just because AWS requires config files and just a whole mess of stuff. So, and that's something that I'm kind of curious about on like, because one thing I really want you to leave here with, is I want to make sure that you have exposure to real systems. Like that was what, like never before have we ran on github.com and used GitHub Actions, which are the standard workflow for everything. It does cause more of a headache because you're using real services. You're using what millions of people are using. You have to use best practice in security. And the thing is with github.com, I don't control it. I can't be like, oh, we'll turn off tokens because it would be easier to not use tokens. Like I don't have any control over that stuff. Like that's stuff that if you use the professional tools, you get all the professional headaches. But I really feel like you are professionals. Like you're going to be changing the world at Microsoft and Google and Facebook. Hopefully, just don't crash Facebook like yesterday. You're going to be changing the world with with using real tools. So I think there is kind of the spectrum. Like, do we want to use real tools? Do we want to do real things? Or do we want to kind of simulate it in a kind of more hand-holdy environment? And like if you're up for the challenge of using real tools, like I'll do the work to make the autograder work with github.com. That's what I've been working on the past few days, is how do I get all the grades off of github.com and make sure like I rerun MP3 for you. So I'll do the work to make sure that we're going to use real tools if that's what we want. But if we're also like, I just want kind of the experience without using the real tool, I'm also okay with that. So, but if we use a real tool, like things are outside of our control. That's the real stuff. Like everything you saw on github.com, I didn't make those error messages. All the struggles you went through to get that going, developing on your real computer instead of having to log onto a VM, like I think that's powerful. I think that's awesome. But there are these struggles that come up, like Macs are different than PCs. So there's kind of a balance of kind of how much real technology you want to use, how much hand-holding, because we could just do everything on AWS, but I think it's so much cooler to build on your own computer. I think that also is going to help you in a job interview. That if you're in a job interview and they're like, oh, can you program this? And you're like, oh yeah, I know how to run C code on my computer. I know how to run Python code on my computer. I can do all of this on my own computer. So I think those are really powerful skills. I think it's what I use every day. It's how I got into Morgan Stanley. It's how I interviewed at Google. So that's what I really want to share with you guys, but I know it's harder. I know it's more difficult. I know it's a struggle. Like I know using real tools suck sometimes. But I can promise like everything we've done, like PNG images, the PNG MP, that's real. Like I didn't make up the PNG specification. Like a bunch of people looked at it and decided this was the easiest way to save images. So there's this kind of divide on like, yeah, could we make an easier format that's easier to deal with? Sure. But I think there's something really cool about being like, I understand exactly how a PNG file is encoded. And that's really powerful. So if you have thoughts about this, I have office hours after class, so I usually sit right outside the classroom as long as there's any questions. Otherwise, I go back to my office until 3. So if you do have any questions at all, or want to just chat or just hang out, say hello, please do. I'll be here for office hours. Remember, there's no lecture on Thursday because you have the exam coming up. So the exam's open right now. If you haven't signed up for the exam, make sure to sign up for the exam. And have an amazing rest of the week. I'll be on Discord and the Campus Wire. So have a great week. I will see you guys next Tuesday. Good luck on the exam.